Hi students, in our previous lectures we have seen time of flight for a projectile thrown on inclined plane. As we had discussed that for a projectile thrown on inclined plane, if we take x-axis to be along the incline and y-axis perpendicular to the incline, we can write. So for the projectile thrown on inclined plane, I want to use a relation for the time of flight which we had discussed for a projectile which was thrown from ground to ground. The result which I will utilize here is that time of flight for a projectile thrown on ground is 2u sine theta divided by g. Here, if we notice, u sine theta is the velocity component perpendicular to x direction at t equal to 0, and g is the acceleration perpendicular to the x direction throughout the motion. So, I had written u sine theta to be the u perpendicular, the component of velocity of projection perpendicular to the surface over which it has been thrown. And on the other hand, a perpendicular, I have taken it as g here because g is perpendicular to the plane on which this projectile has been thrown. So I will modify or rewrite the time of flight for this projectile to be equal to 2 times u perpendicular upon a perpendicular. Remember, here u sine theta, I have written it u perpendicular, and g is the a perpendicular, means perpendicular to the plane over which this projectile had been thrown. And if we resolve a projectile's motion which was thrown on inclined plane in two mutually perpendicular directions, what change we are doing here is we are taking x direction along the incline instead of along the ground, and y direction perpendicular to the incline. If we use this reference frame, then what we observe that velocity of projection has the two components. One component along the incline, it is u cos theta, and other component which is perpendicular to x direction is u sine theta. As we had discussed earlier, for the formula of time of flight which we had written 2u perpendicular divided by a perpendicular, we find the value of u perpendicular here for this projectile, and it is no doubt u sine theta. So I am taking u perpendicular as u sine theta, and as g is vertically downward, so its one component which is g cos alpha will be perpendicular to the plane over which this projectile has been thrown. So I will write a perpendicular to be equal to component of g perpendicular to the incline, means g cos alpha. So by using the similar type of relation, we can get time of flight of this projectile on the incline equal to 2u sine theta divided by g cos alpha. Now, I think You got the correct situation here. If you are not finding it is easier to understand this concept, then you can also use very similar method based on equation of kinematics s equal to ut plus half at square. You can use it to get the same result. I am doing the same result with that particular process so that you may get the clear cut idea and by what way I have taken it in this manner, you can be able to understand that also. So my alternative method to get the time of flight will involve the use of s equal to ut plus half at square for the projectile, and for this projectile we can say u vector, it is equal to u cos theta I cap plus u sin theta j cap. Acceleration vector A can be written as minus g sin theta g sin alpha I cap minus g cos alpha j cap. So using these values into this equation, we can get displacement of the projectile in the taken reference frame to be equal to u cos theta I cap plus u sin theta j cap multiplied by time t minus half g sin alpha I cap plus g cos alpha j cap multiplied by the time t, which finally reduces to s equal to u cos theta minus half g sin alpha t square I cap and u sin theta t minus half g cos alpha t square, it is j cap. We can say here this component of the displacement is along y direction j cap. So, and this component is x displacement is in one complete time of flight, y displacement of projectile is 0. So u sin theta t minus half g cos alpha t square, it is equal to 0. or time of flight t is equal to twice u sine theta divided by g cos alpha. Now you can easily understand what the time of flight is. I have obtained the same result using two different phenomena, two different concepts, and using different concepts also I got the same answer. No doubt the first one method was smart method, while the second method is usual, a descriptive result which we got here. So if we use the time of flight t as we had done here, this result is also of the same type, same form. You can see here the u sine theta is u perpendicular, and this term g cos alpha is a perpendicular. If theta is equal to alpha equal to phi, say, then time of flight becomes 2u upon g tan phi. Now we will utilize this time of flight to calculate the range of the projectile along the incline. Obviously, we can do it in two different methods. I will first go with the traditional method, and after that, I will give you some alternative method which will reduce our calculation part. So first, I am going to discuss the traditional way of getting range along the incline, as ux is equal to u cos theta, ax equal to minus g sine alpha, and time of flight t is equal to 2u sine theta upon g cos alpha. So range R can be calculated using R equal to uxt minus half ax into t square, or R equal to u cos theta twice u sine theta divided by g cos alpha minus 1 by 2 g sine alpha twice u sine theta divided by g cos alpha square. So R finally, so R can be written as, so this relation now reduces to 2u square cos theta sin theta cos alpha minus sin alpha sin square theta divided by g cos square alpha, or R is equal to twice u square by g sin theta cos theta plus alpha divided by cos square alpha, which is the final result for the range along the incline. This is the angle of projection above the incline. This is the angle alpha. The velocity of projection is u. What will we do here to achieve this result is the matter of concern. How can we minimize our calculations? Just see here. If we take reference frame such that x-axis lies along the horizontal and y perpendicular to the ground, means along the vertical direction. Y-axis is vertical. Now, say this projectile finally hits this inclined plane at this point, say it is A. This position is taken as the point of projection, say it is O. We have to find distance OA, which will be the range. Now, to get the answer, what I do here, just mark perpendicular to the x-axis, which meets x-axis at this point. So this point is B. We can easily say that here ux, the velocity of projectile along the horizontal, can be written as u cos theta plus alpha. And as we know, time of flight here is again twice u sin theta divided by g cos alpha. So, distance from O to B or B can be written as u cos theta plus alpha multiplied by the time of flight 2u sin theta divided by g cos alpha. It is the displacement, x displacement of the projectile in one time of flight. So, OB is equal to twice u square by g sin theta cos theta plus alpha divided by cos alpha. Now, range along incline are basically equal to OA, which can be written as OB upon cos alpha from triangle OAB. So range R finally becomes twice u square by g sine theta cos theta plus alpha divided by cos square alpha, which is the same result as we got in our previous approach. This is the range along incline. I think it seems quite easier to use some trigonometrical relation, hypotenuse equal to base upon cosine of the angle. So using that fact, we just achieved this result in 2 or 3 steps only. So I can say here, sometimes rotation of axis gives significant aids to calculations in physics. For range along projectile for range along the incline to be maximum, theta must be pi by 4 minus alpha by 2, where alpha is angle of inclination for projectile thrown up the incline R maximum is equal to u square by g 1 plus sine alpha. For projectile down the incline, so for projectile thrown up the incline, R maximum is equal to u square upon g 1 plus sine alpha, where alpha is the angle of inclination of inclined plane. And for projectile down the incline thrown from up the incline towards the down, for projectile down the incline, this maximum range becomes u square upon g 1 minus sine alpha.